Look at this question. The chapter is over. Okay, I am discussing problems. A woman starts from her home 9 a.m. A woman starts from her home at 9 a.m. Walks with a speed of 5 km per hour on a straight road up to her office 2.5 km away. Stays at the office to 5 p.m. and returns home by an auto with a speed of 25 km per hour. Choose suitable scales and plot xt graph. Position time graph we have already studied. All of you please listen. Okay, I will interact with you. Let me begin this question. Okay, have you understood the question? A woman starts from her home at 9 a.m. Look here, this is H home and this is office. I am just drawing a rough diagram. Woman starts from her home and going to office. Starts from her home at 9 a.m. Walks with a speed of 5 km per hour. The woman starts from her home and walks with a speed of 5 km per hour. Uniform speed. 5 km per hour. Starting at 9 a.m. 9 a.m. And this is office. Let me explain a few things. After that I will interact with you. You can ask me doubt. She is going to office from home. Okay, leave the home at 9 a.m. Walks at a uniform speed of 5 km per hour and reaches office. Straight road. The distance between home and office is 2.5 km. Understood? Straight road. The distance between home and office is what? 2.5 km. She stays at the office till 5 p.m. She is sitting at the office till 5 p.m. She leave the office at 5 p.m. Return to home. Let me draw like this. This is return path. She leave the office at 5 p.m. She leave the office at 5 p.m. and return home by an auto. Understood? Return home by an auto. The speed of the auto is 25 km per hour. Given in the question. Choose suitable scales and plot xt graph. So, okay. So, till this step, are you okay? Raj, Aaron, the question is clear. You understood the question, Fadil?
Yes, sir.
Okay. If you have understood the question, if you have understood this till this part, if you have understood, please raise your hand. Raj understood. Aaron, Aryan, Ingersoll. Who is this Ingersoll? Please respond. Fadil, okay, understood. Deva, understood. Okay, so I am going to draw xt graph. Okay, I am going to draw the xt graph. Xt graph means on x-axis we will mark the time. Understood? On x-axis we will mark time and on y-axis we will mark the position. Xt graph. So she start her journey, starting from home at 9 a.m. 9 a.m. Let this be the starting. Okay, this is 9 a.m. The time I am going to mark the time, starting time 9 a.m. I am not marking 0 here. Instead of 0 I am going to mark 9 a.m. because at that time she leave home. Understood? So leave home at 9 a.m. and she walks at a uniform speed of 5 km per hour. The distance she has to travel is 2.5 km. Look here. In 1 hour she can travel 5 km. 5 km per hour. What is the meaning of that? What is the meaning? In 1 hour she is able to travel 5 kilometer. Let me write here. In 1 hour, she is able to travel 5 kilometer. That is the meaning of 5 kilometer per hour. But she has to travel only 2.5 kilometer. The distance is 2.5. So for 5 kilometer, she has to spend 1 hour. But she need to travel only 2.5 kilometer. So for 2.5 kilometer, she need to spend only half an hour. It's very simple. 5 kilometer per hour speed means that in 1 hour she can travel 5 kilometer. That is the meaning. In 1 hour she can travel 5 kilometer. The distance she has to travel is 2.5. So for 2.5 kilometer she need half an hour, because 2.5 is half of 5. So 2.5 kilometer journey she need 30 minutes time. 30 minutes time. I will interact with you, but let me write here. So she start her journey at 9 a.m. So at 9:30 a.m. Let me write here. At 9:30 a.m. she will reach office. So the position here 2.5 kilometer using suitable scale that is mentioned here. So 2.5 kilometer journey, right? Let me write some here, something like 0.5 kilometer. We have to use some scale. 1 kilometer, 2 kilometer. Sorry. Oh, that much scale is not necessary. I want a smaller unit. 1 minute. Smaller scale. 1 to 2.5, right? 1 kilometer, 2 kilometer, 3 kilometer, like that. On y-axis, we are marking position. So in 30 minutes time, she will reach office. So if she starts her journey at 9 a.m., at 9:30 a.m., she will cover 2.5 kilometer. Understood? So let me, it is a uniform velocity. If the uniform velocity, the position time graph will be a line. We have studied already. I have already discussed that. If the motion is uniform velocity, I have already discussed the motion is under uniform velocity, then xt graph will be a line. So at 9:30 a.m., she will cover 2.5 kilometer, meaning that she has reached office at 9:30 a.m. Okay. Till this step, all of you clear? Raj, Aaron, Aryan, Fadil, Devasri, are you okay? If you have understood till this step, please raise your hand. If you are okay with this step. Everyone is clear? Okay, you must raise your hand. If you understood, you must raise your hand. If you don't understand, please ask me doubt. Everyone is okay. Now, at 9:30, she is sitting at the office. She is sitting at the office till 5 p.m. Please read the question. Stays at the office up to 5 p.m. So 9:30 to 5 p.m. Here you may leave some space. No need to write 10 a.m., 10:30 a.m., 11 a.m. Not required, no problem. You will get the mark. Leave some space. Leave some space. Here she's leave the office at 5 p.m., right? You may leave some space here, no problem. She is sitting at the office till 5 p.m. means she is not moving. Sitting at the office means she is not traveling. Between 9:30 and 5 p.m. her position is fixed. She is sitting at the office, so position is fixed till 5 p.m. She is still 2.5 kilometer away from her home. Till 5 p.m. her position is fixed. She is not moving, sitting in the chair. After 5 p.m. what she do? she is leaving the office and returning to home. After 5 p.m. she is leaving the office and returning to home. So to 25 kilometer per hour is our speed. Let me write here, there is no sufficient space. The return path, I am talking about return path. She is returning to home by an auto. The speed of the auto is, in 1 hour the auto can travel 25 kilometer. That is the meaning of this speed. In 1 hour the auto can travel 25 kilometer. Let me write here, I am talking about return. 25 kilometer per hour means that in 1 hour the auto can travel 25 kilometer. But auto need to travel only 2.5 kilometer. The distance between home and office only 2.5 kilometer. So auto does not need to travel 25 kilometer. Auto need to travel only 2.5 kilometer. For 25 kilometer journey, the time required is 1 hour. And what about for 2.5 kilometer journey, how much time is required? So it's very simple. Just dividing left side and right side by 10. 25 becomes 2.5 by dividing by 10, right? 25 becomes 2.5 by dividing by 10. So left side also divide by 10. Before that, let me explain one thing. 1 hour means 60 minutes, right? I will definitely interact with you. I will clarify all your doubt. Let me complete this. 1 hour means 60 minutes. Is it correct? 1 hour means 60 minutes. Let me write like that. The auto takes this much time. For 25 kilometer journey, the auto will spend 60 minutes time. But auto has to travel only 2.5 kilometer. So the 25 becomes 2.5 by dividing by 10, right? So if I divide right side by 10, the left side also to be divided by 10. 60 by 10 will be 6. So for 2.5 kilometer journey, the auto will spend 6 minute time. So what I have done is left side and right side divided by 10. If I divide right side by 10, I get 2.5. So I have to divide left side also by 10. So for 2.5 kilometer return journey, the auto will spend 6 minute time. She leave the office at 5 p.m. She leave the office at 5 p.m. So she will reach home at 6 p.m. Because only 6 minutes is required. Understood? Only 6 minutes is required for the return. Understood? She is returning to home by auto. So only 6 minutes is required. She leave the office at 5 p.m. Then she will reach home at 6 p.m. Okay, 5 hour 6 minutes, like that. The return path is also uniform speed, uniform velocity. So I explained in the previous classes, for a uniform velocity, the position time graph will be a line joining. So at 6 p.m. her position will be 0. The position is measured from home. So at 6 p.m. her position is the initial position itself. So position will be 0 at 6 p.m. So this is the position time graph. That is our question. Okay. All of you please write down, draw the diagram. No need to take any graph sheet. On white paper you can draw a rough sketch. If you have any doubt, please ask me. If you have any doubt, you please ask. If you have drawn the graph and no doubt, then raise your hand. Aaron clear ആയല്ലോ അല്ലേ? ആരോൺ ഇത് ഓൾറെഡി അറ്റൻഡ് ചെയ്തിട്ടില്ലല്ലോ ഈ പ്രോബ്ലം അല്ലേ ആരോൺ? അറ്റൻഡ് ചെയ്തിട്ടുണ്ടായിരുന്നു അല്ലേ? ഓക്കെ. ആരോൺ ഇന്നത്തോടെ തീരോട്ടെ. നമുക്ക് നെക്സ്റ്റ് ക്ലാസ് മുതൽ എന്തായാലും ന്യൂ ചാപ്റ്റർ ആണ്. ഫാദിൽ, ആര്യൻ, എവ്രി വൺ. ദേവശ്രീ, യു അണ്ടർസ്റ്റുഡ്? ദേവശ്രീ, clear?
Yes, sir.
Okay, so everyone finish. Let me discuss the next one. I'm discussing numericals. The 2.5 is simple, but numerical problem. So let me discuss. I will read the question. A car moving along a straight highway with the speed 126 km per hour is brought to a stop within a distance of 200 meter. What is the retardation of the car? It is a very simple question. In the previous classes we studied three formulas. These three formulas, one of the formula is required. In the previous class we studied three formula for if the motion is moving under a uniform acceleration. If there is a uniform acceleration, we have three formula. We need one of the formula. In the previous class I derived this formula also. Okay, so in this question, all of you please listen. A car, suppose this is a car moving along a straight road, with a speed of 126 km per hour. The initial velocity is 126 km per hour. Our standard unit is meter per second. You know that. Understood? Meter per second is our standard unit. Anybody, how will you convert kilometer per hour to meter per second? Anybody? Please respond. Raj, do you have any idea? Converting kilometer per hour to meter per second. Is there any way?
Sir,
Yes, tell me.
sir, 126 into 18 by 5, sir.
No. 5 by 18. 5 by 18. So please remember, don't forget it. Kilometer per hour should be converted to meter per second. Meter per second is the standard unit of velocity. Can be converted by multiplying with the 5 by 18. Okay, if you don't remember, I discussed earlier. If you don't remember, please write it. Kilometer per hour can be converted to meter per second by multiplying with the 5 by 18. Remember, meter per second is the standard unit of velocity. So 126 to be multiplied with the 5 by 18, we get meter per second. Understood? What is this 126 by 18? 1 minute, let me do it. Calculation I don't want to discuss. 126 into 5 divided by 18. You will get 35. Calculation I don't want to discuss. The initial velocity is 35 meter per second. I will give you one question. Listen carefully. I will give you a question. The initial velocity of the car is 35 meter per second. Okay, initial velocity of the car is brought to stop with a distance of 200 meter. Brake is applied on the car after traveling 200 meter. The car stop. Understood? Car stop, brake is applied. Understood? A brake is applied. As a result, the speed gradually decreases. Ultimately, the final velocity becomes 0. The car stop after covering a distance 200 meter. What is the retardation? Retardation means it is simply acceleration having negative sign. Retardation is actually acceleration. There is a change in velocity, right? The velocity is decreasing, there is a change in velocity. The change in velocity by time is acceleration. Retardation, okay, that is also acceleration. Retardation means negative acceleration. Retardation means negative acceleration. Acceleration having negative sign is said to be retardation. Okay, anyway, all of you please listen. U is given, V is given, S is given, A is our question. U, V, A, S. A is our question, right? U, V, A, S. Is there any formula connecting all the four letters U, V, A, S? Anybody? Is there any formula connecting U, V, A, S? Anybody?
Sir, V square minus U square is equal to 2A.
Ah, yes. We studied in the previous class that V square equal to U square plus 2AS. I derived this formula. Understood? UVAS. The formula connecting UVAS is V square equal to U square plus 2AS. You have to substitute the value V equal to 0. Understood? Let me complete it. After that you can ask me doubt. Okay? V square will be 0 square equal to U is 35. U is 35. 35 square plus 2 into A into S. S is 200. So right side will be, what is this? This is 400A, right? And this 35 square, okay, can be taken to the other side. I don't want to explain all the steps. 35 square is taken to the other side, minus 35 square in the other side. Clear? This one taken to the other side. 400A equal to minus 35 square, that is minus 35 into minus 35 into 35. I want acceleration. 400 go to the other side. We can reduce. Calculation, let me avoid. Okay, I don't want to explain calculation. If I explain all multiplication, division, it will take time. Okay, 1 minute. Approximately 3.1. Okay, minus 3.1. I don't want to discuss the calculation part. Let me skip. Minus 3.1 meter per second square is the unit of acceleration. Retardation means acceleration having negative sign is said to be retardation. So in this case, retardation we will find A. There will be a negative sign. So all of it clear? But 1 minute. I did not read the question. What is the retardation? Okay, that is I have found it. There is one more question. After finding acceleration, there is one more question. How long does it take for the car to stop? The time is also I want to find out. How long the car take to stop? Time. The traveling time. Okay, the time I want. So UVAT, A I got right now. Any formula UVAT? Here minus 3.1, you may approximate it as 3. Actually I got minus 3.0 something. So we can approximate. If you do approximation, there is no problem. A equal to approximately minus 3. Now there is one more question. The traveling time of the car. How long the car take to stop? Understood? So T I want. UVAT. A I got right now. UVAT. Is there any formula connecting UVAT? Is there any formula connecting UVAT? In the previous class, UVAT, we studied one formula V equal to U plus AT. I got the value of A. So VUVAT, understood. Or you may use the formula S equal to UT plus half AT square, but this formula is much better. V equal to U plus AT, V equal to 0 final velocity, U equal to 35, A equal to minus 3 into T. Time, traveling time. 3T equal to 35. T equal to 35 by 3. You will get approximately 11.7 seconds. 11.7 second. Okay. So please write down. All of you please write down. If you don't understand any step, please ask. If you have written and no doubt, then raise your hand. If you have written and no doubt, then raise your hand. Aaron understood, right? You can remove Devasri, Fadil, Raj, Aryan. Everyone is clear. Everyone is okay. Fadil is okay. Okay, so we can go to next problem. Okay. I am discussing the selected problems. Aaron തന്ന question ഞാൻ ചെയ്യാം കേട്ടോ. ഓക്കെ, ഞാൻ അടുത്ത ക്ലാസ്സിൽ ചെയ്യാം കേട്ടോ. ഓക്കെ ആരോ. 2.6 is a tough question. 2.6 really a tough question. I will discuss that. Okay, 2.6. It is about the sign of velocity, acceleration, etc. So 2.5 I discussed. I select the important problems. Let me discuss 2.6. Actually a tough question. Let me reduce the size. You may zoom. Okay, you may zoom it. If it is not visible, you may zoom. I will read the question. All of you please listen carefully. It is a tough question. A player throws a ball upward with an initial speed of 29.4 meter per second. What is the direction of the acceleration during the upward motion of the ball? Direction of the acceleration. Most of the students have doubt about that direction. Acceleration has magnitude as well as direction. Let us draw a rough diagram. Okay. A ball is thrown upward, right? Is it correct? I have a ball. A ball is thrown up with the initial speed 29.4 meter per second. A ball is thrown up. You know that its velocity will be decreasing, and finally the ball stop and will be falling down. Understood? It will return to the ground. Suppose the stone is moving upward. Okay, look at the path. The stoning is moving upward. Question is, what is the direction of the acceleration during the upward motion of the ball? Anybody? What is the direction of the acceleration? Anybody? Raj, Aaron, Fadil. Direction. Aaron അറിയാമോ? Aaron.
Yes sir.
എങ്ങനെയാണ് ഡയറക്ഷൻ വരുന്നത്?
Upward.
No, not upward. Most of the students are confused with the first problem. Downward. I will tell you the reason. In 9th standard, to find the direction of acceleration, you think about force. Please think about force. You studied in 9th standard physics. In 9th standard physics, you studied one formula, and also there is a chapter laws of motion. You will learn later. In the chapter laws of motion, we have a formula F equal to ma. F equal to ma. F is the force we are applying on the body. Actually, you studied in 9th standard. Okay, you will remember that. Okay, there is a body. I am applying a force. I am applying force. If I apply force, it will have acceleration. If it will have acceleration, right? F equal to ma, you will learn it later. Actually, you studied in 9th standard. So F equal to ma. So please remember that F and A both having the same direction. If F is applying forward, acceleration will also be forward. Because F equal to ma means A equal to F by m. I can write like that. A equal to F by m. So acceleration is maybe defined as the force per mass. I can define acceleration as force by mass. 1 kilogram experience how much force. So in simple language, what I can say is acceleration and force both having same direction. Regarding direction, we can say like that. Acceleration and force both having same direction. If force towards right side, acceleration will be towards right, because of this formula. Okay. So force, and you may please remember, this is much convenient. If force and acceleration, a body will have acceleration only if a force is applied on it. A body will not have acceleration if no force. So body will be accelerated only if some force is acting on it. So F and A have same direction. Same direction. Okay. So to find the direction of acceleration, actually you need not look at the direction of the motion. You need not look at the direction of the motion. To find the direction of the acceleration, what is the force experienced by the body during the motion. During the motion, what is the force experienced by the body. Whether the body is moving up or down, the body experience a downward force because earth attract it downward. Understood? Gravity. It is said to be gravity. Whether the body may be going up or may be going down, whatever it may be, the body experience a force downward. Earth attract the body. So since the force is downward, the acceleration is also downward. I told you F and A have same direction, so the acceleration is not upward. The motion is upward, but acceleration is not upward. The direction of the acceleration is same as the force experienced by the body. So the first question answer is acceleration. Let me give some symbol like this. Acceleration downward. Acceleration is defined as a force per mass. 1 kilogram body experience how much force. Okay. So first question I have answered. The direction of the acceleration is not upward, it is downward. All of it clear? Understood? Raj, Fadil,
Yes, sir.
Devasri, understood? Devasri, clear?
Yes, sir.
It is a tough question. It will take time. Okay, discussing all these 4 questions take time. The second question I am going to answer. Second question. What are the velocity and acceleration of the ball at the highest point of the motion? Highest point is this one. Understood? The highest point, what is the velocity and acceleration here? The body has reached the highest point. At that instant, what is the velocity? What are the velocity and acceleration? Anybody at highest point? Anybody, what is the velocity? Anybody?
0, sir.
0. Yes. The body is stationary. Understood? Understood. At that moment only. At that moment, the body is stationary and going to fall downward. At highest point, the body is instant. At that instant, the body is stationary. At that instant. At highest point, the velocity is equal to 0. Most of the students write that acceleration is also 0. They say the reason as the body is stationary, so no acceleration. Many students reply like that. The body is stationary at the highest point, so acceleration also 0. It is wrong actually. I told you that the acceleration is force experienced by the body. 1 kilogram body experience how much force? At the maximum point, the body still experience a downward force. Understood? The body still experience a downward force. The acceleration due to gravity you studied in the lower classes. If you don't know, you please remember the value. 9.8 meter per second square. Downward. Why downward? Acceleration is actually a force, downward force per unit mass. So at the maximum point, the body is stationary, but still the body experience a downward force. If there is force, there will be acceleration. Whenever there is force, there will be acceleration. Body still experience a downward force. So body still has acceleration 9.8 downward. The acceleration will be there at the highest point 9.8 meter per second square downward. All of you please write these two solutions, A and B. Then I will explain C and D after that. All of you clear? The second part is okay? Please respond.
Yes, sir.
If you are okay, if you have written, please raise your hand. If you have written, please raise your hand. Devasri clear. Fadil, Raj Singh, Aryan, Aaron, Rakshana understood. Everyone is clear. Okay, so let me go to the next question, C and D. Okay, I am going to discuss C and D. 1 minute, 1 minute. I am going to discuss C and D. Sorry. A and B I have already discussed. Now I am going to discuss C. C is a tough question. Choose x equal to 0 meter and t equal to 0 second to be the location and time of the ball at the highest point. Vertically downward direction to be positive direction of x-axis, and give the sign of the position, velocity, acceleration of the ball during its upward and downward motion. It is really a tough question. C, D not a tough, but C is a tough question. Okay, all of you please listen. Please remove your raised hand. Please remove your raised hand. A stone is thrown upward with an initial velocity 29.4 meter per second upward. The body is going upward and reaches the maximum point, right? Reaches the maximum point. After that the body will be going downward, return to ground. It will be returned to ground. The question says that choose x equal to 0 meter and time equal to 0 second to be the location and time of the ball at the highest point. Vertically down. Okay. X equal to 0 meter. Okay, I am going to draw a number line. All of you please listen. This says that at highest point the position is 0. They says that we must mark x equal to 0, means position equal to 0 at the highest point. This is the highest point. At the highest point we mark the position as 0. They explained in the question, so we have to mark it. And vertically downward direction to be positive direction of x-axis. So vertically downward, all of you please listen, vertically downward to be positive direction of x-axis. So let me draw an axis. This one is origin, understood? Let me draw an axis. Let us call it as x-axis. This is the positive direction of x-axis. So I have to mark 1, 2. This is positive side, understood? This is positive side of x-axis. So plus 1, plus 2, plus 3, plus 4, etc., etc. I will mark. Why I am marking plus 1, plus 2, plus 3 downward? Because they clearly says that the vertically downward direction to be the positive direction of x-axis. This is 0. We have to mark this point as origin, and this downward direction as the positive direction of x-axis. Means that I have to mark plus 1, plus 2, plus 3, plus 4, etc. downward. The position to be marked like this. The other part minus 1, minus 2, but it is not required. Okay, the body will not go beyond O, will not go up beyond O. So 1, 2, 3, 4, etc. I hope you have understood. So till this step you are okay? Till this step, please respond. Raj, Deva, Aryan.
Yes, sir.
Okay. So I have marked the position actually. These are the position. This is the positive direction. Hence plus 1, plus 2, plus 3, etc. marked. This is 0. Origin. Okay. So what is our question? Vertically downward. Okay. And give the sign of position, velocity and acceleration of the ball during the upward and downward motion. So during upward motion, what is the sign of position, velocity, acceleration? So upward motion. Okay. Let it be case 1, upward motion. I am talking about upward motion. I will draw a separate diagram for downward motion. Here I am talking about upward motion. Let this point be some number. Give some name. Give some number. You will not have any confusion then. Let it be plus 5. Okay. Ground plus 5. Give some number there. Okay. The body is going up from 5. The body is going up from plus 5. So position changes from plus 5, plus 4, plus 3, etc., etc. The position changes like that. Plus 5, plus 4, plus 3, plus 2, etc. Understood? What is the position? The sign of the position. Not displacement. They are not talking about displacement. Position. Plus 5, plus 4, plus 3, plus 2, plus 1. All these numbers are positive number. Understood? Position is positive. They are not talking about displacement. They are talking about position. During upward motion, the position is positive. Plus 4, plus 3, plus 2, plus 1, etc. are positive. So for upward motion, position is positive. They are not asking for displacement. They are asking for position. Plus 5, plus 4, plus 3, etc. Are they positive? Yes. Is it okay? Position positive. All of it clear? All of it clear?
Yes.
Next is velocity. Position, velocity. How will you find it? Velocity. Anybody? Please tell me. Anybody? What is the sign of the velocity? Upward motion. Upward motion. What is the sign of the velocity? Anybody? Aryan, Fadil, Aaron. Upward motion. What is the velocity? All of you please listen. For one-dimensional motion, I have already discussed that. If the body is moving towards positive direction of x-axis, velocity positive. We have already studied this. I have already discussed that. Moving towards, let me write it once again. Towards positive side of x-axis. Positive direction of x-axis. I have discussed this, okay. A body is moving towards positive direction of x-axis. Positive direction of x-axis. In that case, velocity is taken as positive. Forward motion. We say that it has a forward motion. A body moving towards positive direction of x-axis, the velocity is taken as positive. but negative direction of x-axis. Negative direction, understood. Negative direction of x-axis, the velocity is taken as negative. This is the way. Is the body moving towards positive direction or negative direction of x-axis? Positive direction means the body has to move back downward. The downward direction is positive direction of x-axis, mentioned in the question.
Negative.
Yes. The body is going upward means it is moving towards negative direction of x-axis. Positive direction means downward, mentioned in the question. Since the body is moving upward, it is towards negative direction of x-axis. So if the body is moving towards negative direction of x-axis, negative velocity. Never forget it. If you don't remember, you may put it in a box. All of it clear? Velocity negative is okay? Please respond. Aryan, Aaron, Devasri, Fadil, Rakshana. Rakshana, you were there from the beginning.
Yes, sir.
Okay. Velocity, then acceleration I have already discussed. The acceleration means force. To find the direction of acceleration, you think about the force. Whether the body may be going up or down. Body may be going up or down, but the force experienced by the body will be downward. Earth attract the body downward. So force and acceleration both having the same direction. I have already discussed. Force and acceleration both having the same direction. The body going upward, that is okay, but the force towards downward. The force towards positive direction of x-axis. Or acceleration towards positive direction of x-axis. So acceleration is positive. The same technique for acceleration also, okay? I mean, for acceleration you think about force, that is sufficient, okay? Just look at the direction of the force. The force towards positive direction of x-axis. Hence acceleration towards positive direction of x-axis. Acceleration is positive, okay? So the first part is over, okay? First part, upward motion, is over. All of you please write down. If you don't understand anything, please ask me. If you don't understand anything, please ask. Aryan, clear. All of you, if you are okay, return, raise your hand. You have to try this one, okay, as homework. After the class, you please send it. If you are not, if you don't understand it, don't worry, I will discuss it, okay? But you take an effort. The upward journey I discussed. Now you have to consider the downward journey. Not difficult, you can understand that. So downward motion, the sign of the position, velocity and acceleration. The three things you have to do as homework. Very simple, okay? If you have understood the first case, the downward motion is same technique, okay? Same principle. So first part I discussed, second part homework. Let me discuss the D. All of you please listen. Let me discuss the D, okay? To what height does the ball rise, after how long, and after how long does the ball return to the player's hands? That is the next question. I will discuss that, okay? 1 minute, I am going to discuss D part. What the question says that a ball is thrown up. A ball is thrown up from the ground with the initial speed 29.4 meter per second. We are throwing up. The velocity will be decreasing, right? And reaches the maximum point. After that, it will go downward. reaches the ground. Understood? To what height? The S I want. The displacement, the distance traveled by the stone I want. S, height means displacement. S is our question. To what height does the ball rise? Initial velocity is given to us. Final velocity is given to us. Sorry, it will be 0. At the highest point, velocity is 0. The body experience retardation, means velocity decreasing from 29.4 to 0. The velocity is decreasing. If the body is going up or down, the acceleration due to gravity will be 9.8. Please memorize that. It should be negative. This is because the velocity is decreasing. Initially 29.4, gradually speed decreases, ultimately speed becomes 0. So there is a decrease in velocity, hence acceleration is negative. UVAS, understood? Is there any formula connecting UVAS? Anybody, please respond.
E square minus U square is equal to A.
Yes. ആര്യനെ മനസ്സിലാവുന്നുണ്ടല്ലോ അല്ലേ? ആര്യൻ ശ്രദ്ധിക്കുന്നുണ്ടല്ലോ അല്ലേ? ആര്യൻ?
Yes, sir.
So UVAS, is there any formula connecting UVAS? We studied in the previous class that V square equal to U square plus 2AS. UVAS, okay? The sign of the acceleration is negative because the speed is decreasing, right? V equal to 0, U equal to 29.4 square. 2 into A is minus 9.8. S is the height, distance travel. 29.4 whole square. 1 minute. Calculation I will not discuss. Okay, you can do it later. 229.4 into 29.4. 864. 864.36. 2 into 9.8 minus, what is that? 2 into 9.8. 19.6. S equal to 0. S means height. Arranging 9.6 S is equal to 864.36. A calculation you can do later. After the class you can try the calculation. Right now I am not discussing. If I discuss the calculation it will take time. 864.36 divided by 19.6. You may take some, you may approximate like 864 by 19, 20. You may do some approximation like this. You will not lose any mark. Okay, if you the approximation like this, there is no problem because the calculator is not allowed. That is why there will be a small error, but don't worry, you will get full mark. Okay. Let me do the division. 1 minute. 864.36. 1 minute. 19.6. You will get a good number actually. 44.1 meter is the height. This is the height. Not completed. To what height does the ball rise? That part is done. Till this step you are okay. Please respond. Till this step you are okay. Please respond.
Yes, sir.
Okay. And the next question is how long does the ball return to the player's hands? The body going up and going down. What is the time taken? Okay, what understood? How long does the ball return to the player's hands? A body is projected upward. How long does the body take to return to the initial position? The initial position is this. Let me denote it by O. The initial position is O. After going up, the body will go downward and finally reach O. So O to O, understood? O to O motion. O is the initial position. O is the initial position. The body going up and going down. Understood? Okay, clear. Moving up and down, the body experience a acceleration. The acceleration is the direction is downward. Understood? The acceleration direction is downward because the force is downward. Whether the body going up or down, the body experience an acceleration minus 9.8. This is because downward, let me call it as negative direction. I am taking that downward as negative. Okay. Even if you take positive, don't worry, you will get the answer. Don't worry. Okay. Anyway, the acceleration will be there even if the body going up or going down. Still, there is a downward acceleration. Even if the body going up, the force downward. If the body is going down, still the force downward. So acceleration will be there minus 9.8. Or if you take plus 9.8, don't worry, you will get the same answer. Okay. So the body return to the same position, starting from O, moving up and moving down, finally reaches O. What is the time taken for this entire path? Starting from O, finally reaches O itself. What is the time taken? So in this case, initial position and final position coincides. The displacement covered by the body will be 0. Why the displacement covered by the body is 0? The body starting from O ultimately reaches O itself. So initial position is O, final position is also O. Understood? Initial position is O, the final position is O. The displacement will be 0. All of it clear? Understood? Please respond. Please respond.
Yes.
Devasri. Okay. So we have a formula S. The body is still moving with a fixed acceleration. Moving up or down, the body maintain a fixed acceleration downward. We have a formula S equal to, do you remember this formula? Ut plus half at square. Do you remember this formula? Please respond. Is there any formula? Yes. We studied one formula, S equal to Ut plus half at square. O to O motion. Starting from O, finally O. S equal to 0. Starting velocity is 29.4. Time taken for the entire journey T, I don't know. Plus half into, there is no sufficient space. I will write in the next page. I will write in the next page. Let me write once again. S equal to Ut plus half at square. I will explain. Okay. If you have any doubt, definitely I will repeat. Don't worry. S equal to 0. O to O motion. Net displacement 0. U is the starting velocity 29.4. Into T plus half into acceleration is fixed, upward and downward. Acceleration is downward force, downward acceleration minus 9.8. T square. T is our question. T is the time taken for the entire journey. You can do one thing, 29.4 T. Don't leave, all of you please listen. This one 9.8 by 2 will be 4.9. Left side is 0. Take one of the term to the other side. Take one of the term to the other side. 4.9 T square equal to 29.4 T. 1 T cancels. T is non-zero number, right? 1 T cancelled. 4.9 T equal to 29.4. T equal to 29.4 divided by 4.9. You can approximate like denominator as 5. Okay, anyway, calculation I am not discussing. 29.4 divided by 4.9. 6. You will get a good answer. 6. 6 seconds. So O to O, understood. Starting from O, finally reaches O itself. The total journey time will be 6 seconds. So all of you please write down. If you don't understand any step, please ask. If you don't understand any step, please ask. If you have written and no doubt, raise your hand. Rakshana Deva Fadil Aryan, clear. Aaron, understood. Okay. So now it is 8:30. Let me wind up the class today. The chapter is over. If you need, I will discuss one more problem, but the important questions I completed. Okay. So let me wind up the class. Okay, bye. If you have returned, you may leave the meeting. If you have any doubt, you please ask.
Thank you, sir. Bye, sir.
Okay, bye.
Thank you, sir.
Okay.